Hello to my favorite MBA cohort. I'm Olivia, and I'll be talking to you today about the use of IT in my group at Kohler, Product Sustainability Engineering. I say it's all about the data because my group primarily does data collection and analysis to provide feedback to the business in order to make factual-based sustainability decisions. It's pretty fun work if I do say so myself. Now, here's a pretty cheesy photo of myself looking at the slag pile in the Kohler landfill, which is not something I do regularly. But what I do regularly is work specifically on product transparency. Essentially, I manage the processes and some of the data we use to distribute documents stating both the environmental impact and material health information for our customers. The customers most focused on this are those in the green building industry who can gain points towards their certifications by simply buying our products that have this documentation. This is not what most green buildings look like, but this is a pretty thought-provoking building. My group consists of 8 people who rely a lot on IT, and we are always working to make our data collection analysis processes more efficient so we can increase our reach. Looking at IT strategy overall, my presentation will focus on process automation, and I will first explain to you the 2 main datasets that my group works with. For the purpose of the IT steps I'll show soon, I'm going to explain the type of data that makes up the 2 transparency documents that we create. The first is called an Environmental Product Declaration, or EPD. One EPD represents one root SKU and lists about 28 pages of environmental impact data for the product. We look from cradle to grave at the entire product life cycle. As you see on the left, we consider the impacts associated with raw materials, manufacturing processes, transportation, consumer use, and end of life. That pretty much covers everything. For this product specifically, most of the data we gather comes from the plant Excel files or IT systems we have in place, such as SAP and Cognos. The data used here is essentially a reconciliation of all the resource inputs and outputs to the product. Each SKU must include impacts from each manufacturing location. Since some SKUs are made in 4+ plants, think about the amount of data we have to gather and time and energy put into this analysis. It can take over 6 months to create one plant level model, and that's being conservative in some cases. Now on to the second transparency document. This is called a declare label, but don't get confused by the word label because it doesn't actually go on the product box as a sticker. It is document posted online. A declare label is essentially a nutrition label for the product. Does anyone remember when nutrition labels weren't required for food? Well, that used to be the case, but now it is required. Consumers are starting to request material disclosures from manufacturers. The data that goes into this document should represent 100% of the finished product down to 0.01% or 100 ppm. This is very detailed data that Kohler does not currently store in our BOMs. I am working on an initiative to integrate this into our NPD process for kitchen and bath currently, so that a product would launch with a declare label if necessary for the desired market. Matt Meyer and Ryan are also part of this team. This information isn't only to help green building customers. What we are really excited about is being able to make proactive decisions on the materials we specify in our products by understanding what we and our suppliers use in our products in the first place. So what does IT Utopia look like for product sustainability engineering? In my utopia, IT and the business is extremely connected. Systems talk to each other, and there is no need to log in and out several times a day. This connectivity would mean more APIs, data sensors to track water and energy use for each piece of production equipment, and all of Kohler's systems are synced and set up the same way, so it isn't like trying to decipher a foreign language when looking at a new plant BOM. Oh wait, many of our BOMs are in different languages, so then SAP would translate this information depending on what your native language is. IT systems would be reliable. Just like Google Docs, everything would automatically save. Data standards would be set up in a way that the data is more reliable through tracking like Internet of Things. Data updates are real time and you never question the validity of a report. Lastly, wouldn't it be great if using software was easy and you could find the data you need by simply thinking about it? Maybe that's a little too far-fetched, but seriously, the learning curve never ends with software and data. There are always exceptions to the standards, and it is definitely not simple. There would be so much more time saved if using IT came naturally. As John Lennon said, reality leaves a lot to the imagination. The reality is that we use a lot of different software tools to house data. Many times we have to rely on specific plant contacts to find the data, and this makes data collection and organization very time-consuming. Imagine trying to refresh our data and understand when things change. It is not an efficient process. The reality is that we have legacy systems, software that doesn't always talk to each other, and data that's housed in many locations. Let's start by looking at the process of how we create an EPD through lifecycle inventory modeling and the inefficiencies that involve IT here. The entire EPD creation process involves about 8 main steps, but we will focus on steps 2 and 3, manufacturing data gathering and lifecycle inventory model data prep. Lifecycle inventory model is what we term the model which calculates the environmental impacts that go into an EPD. When thinking about how to show the horrors of IT and data as it relates to lifecycle inventory modeling, it's kind of hard, but the main point is that one of the most time-consuming parts of this whole process is simply the data gathering and organization. Just look at the Excel files on the left. Each Excel file is a calculation of one electricity factor that goes into just one line of the spreadsheet on the right. And that spreadsheet has over 200 rows of raw material, electricity, natural gas, water, and waste factors built up. The data and information used to build this up comes from utility bills, SAP BOMs, process maps, individual equipment metering tests, and many more. I can dream of several ways that IT could be used to improve this. Next, we'll take a look at the declare label creation process. Since we are gathering data retroactively for declare labels, we have a lot of steps to go through. The first is to use SAP to extract the BOM into a macro-enabled Excel spreadsheet. Next, we determine all the suppliers for every material in the BOM, excluding packaging. We then go to the drawings housed in Windchill to determine what each component is made out of. There is never enough info on the material spec since we need data down to 0.01%. So we next turn to the Kohler Safety Datasheet database to search through hundreds of SDSs to see if we have one for the material and correct supplier used in a component. A lot of the times we don't find them, so then we'll have to reach out to the supplier for more information, and when it's all completed, we have a massive spreadsheet of information that then has to be imported into ToxNet. If we think about my utopia, can you see how connected systems that are reliable and simple to use would help make this process much more efficient? The last step of sending the data to the standards organization for publishing is so easy. The reality of this is actually pretty great. I just push a button and almost all the information needed to create this document is transferred where I need it. ToxNet has an API in place to do this, and it really saves time and energy. Although the reality is that we have a long way towards utopia, there are solutions we are already working on to move us towards a more connected, reliable, and simple process. For example, one of the main issues with the declare label creation process now is that we are doing this work retroactively. We are gathering data from many different software systems and compiling them into ToxNet to help create the label. We currently have a cross-functional team looking at how to integrate the declare label creation process as well as healthier material selection into the NPD process. Our hope is to gather the data up front so that what's called a product material health BOM can be stored in Windchill, linked to individual SKUs in SAP, and uploaded to ToxNet. During our learning process, we've discovered that Faucets already completes a Faucets lead calculation that is somewhat similar to the Product Material Health BOM, except focused solely on lead. We're looking at taking advantage of the systems in place to organize and track the Faucets lead calculation so that we can streamline the Product Material Health BOM in a similar manner. There are still many questions as to how this will work, but by proactively gathering the data necessary for a declare label, this will cut down on the amount of time spent utilizing SAP, Windchill, SDS Online, and supplier letters to retroactively gather this data. Also, the use of ToxNet as our tool allows us to scale our approach. Another solution to help streamline our process involves our relationship with ToxNet. We have a great relationship built with them and work with their programming team weekly to improve the platform. We will be working with them to set up APIs between databases that designers and architects go to in order to find declare labels, such as Mindful Materials and UL Spot shown here. We hope this will also work with Kohler as well, but I have not checked into our policy on this and am expecting that there may be some hurdles to work with. With these APIs in place, it will allow us to easily publish declare labels and update them in real time. Without this, there is a lot of communication and manual entry work that must be done to push declare labels out to these platforms. SEMA Pro, our main LCI modeling software that helps us create EPDs, has a new add-on called Share and Collect. We're still learning how to use this, but the hope is that it will help us collect information from manufacturing and potentially even suppliers about their environmental impacts so that we can link this with SEMA Pro. This could be an alternative to sending Excel files through email. In another cross-functional effort, we are working with communications, technical communications, and marketing to streamline the EPD creation process so that it will look more like the spec sheet process. One of the tools which will enable this process is a new software that Technical Communications recently purchased. Because we've identified this need, they are working to build it in as they switch document creation to the new platform. Currently, the EPD process has very little automation, but the new process will be semi-automated. This will allow us to respond to customer requests more quickly and give us time to work on many other initiatives. These are just a few ideas we are working on to help better integrate our IT systems with my group. Oddly enough, I can't say I know anyone specifically who works in IT, which makes me believe that Kohler has a more decentralized structure. I hope our future with IT and product sustainability engineering looks as bright as this, but I think we have a long way to go. Thanks for listening.